My name is Ali Reza Zendeboudi from Norwegian University of Science and Technology, based in Trondheim, Norway. And I will present the slides for the heat pumps with the natural refrigerants today, covered by 3HP project. I'm getting back actually to the fundamental question, why the natural refrigerants actually. So here actually in these slides we have the development for the refrigerants, starting from the first generation here, which actually we use the natural refrigerants. And later the second generation introduced CFC and HCFCs for the concept to be safe as a replacement for the ammonia, which was really popular at that time. However, after a period of time using, we faced actually with the problem with the ozone layer. So the third generation introduced the concept for the HFCs, which continued by around 2010. As a replacement for the ozone layer protection, we found actually the problem with the global warming, and recently the fourth generation HFO actually introduced to avoid the global warming. However, the consequence is the impact on the human health. So with the advanced actually technologies, the researchers getting back again, working on the natural refrigerants such as CO2, ammonia, water, propane, and so on and so forth. So we do believe that only the use of natural refrigerants for the heat pumps can be considered as a long-lasting solution, and that's what we need actually to focus on for the sustainable environment, sustainable actually technologies. All right, so through 3HP project, as my colleagues mentioned, we developed three natural-based refrigerant heat pump systems. So the first actually prototype is based on the CO2 refrigerants for the buildings. When the domestic hot water is dominated, we utilize the concept for the auxiliary system, the tripartite gas cooler to improve the efficiency of the unit, and also we utilize the ejector technology to reduce actually the compressor work and also recover some of the losses that we face actually. So the second prototype is based on the propane refrigerant when the space heating is the matter inside of the buildings. We develop actually two different types. So the first one based on the propane is based on the ground source, and the second one is based on the concept of auxiliary or the evaporator supercooler, which I explain actually later a bit. So here we have actually the concept for both of the heat pumps which develop under the 3HP. So the first one is based on the auxiliary, as you can see here on the left side. Here we have actually the heat pump, the auxiliary, and also the demand for the heating and cooling. Of course, we have the PV, solar thermal, and advanced actually control strategy. And on the right side, you have the concept for the dual source heat pump system, where we have actually the heat exchanger here, heat pump, and also the demand here, as you can see it here. All right, so the first prototype is the CO2 ice heat pump system. Here we have the figure, the schematic for the heat pump. So we use actually the tripartite gas cooler. Why? Because we were able actually to combine the domestic hot water and space heating functions together. We were able actually to improve the temperature match between the CO2 and water, which results into the improvement of the efficiency of the system. And by using the brazed plate heat exchanger, we were able actually to make a compact and high efficient system. We tested actually the heat exchangers at Anthony University, and finally we built up actually the unit in Switzerland. But how the system works? The high temperature, high pressure refrigerants getting out of the compressor passes through the tripartite gas cooler, comes inside of the internal heat exchanger, ejector, evaporator, separator, and then going to be the suction inside of the compressor. On the other side, into the counterflow, we have the domestic hot water inlet temperature, the tap water around 10 to 12 degrees Celsius, going to be preheated actually from 10 or 12 to, let's say, 40 degrees Celsius. And also going to pass through the gas cooler 1, which going to reach to up to 65 to 70 degrees Celsius, going to be supplied to the temperature. For the gas cooler 2, We have the space heating inlet temperature and outlet, which is going to be on the design condition 30 degrees Celsius, and the outlet is 35 degrees Celsius. So the system is able to work only on under the domestic hot water operation, only space heating, and also is able to work under the combined mode to have the domestic hot water and the space heating at the same time. The second prototype is the propane ice heat pump system. The system also is able to work under only the space heating, only domestic hot water, and also the combined mode. Here we have the schematic actually for the unit. The inlet of the desuperheater is the outlet of the compressor. Passes actually the refrigerants through the desuperheater and also the condenser and goes actually to the evaporator. We have actually the counterflow here. This is the concept, only the green one when we want to use the system for the domestic hot water production. We use the condenser for the preheater and the desuperheater for the reheater for production of domestic hot water. And here on the left side, we have the schematic when we want to use the system under the combined mode or only the space heating. We're going to use the condenser for the space heating production. And on the combined mode, we use actually the red one for production of domestic hot water when it's under the combined mode, actually, the system. The last actually prototype which we developed is the concept for the propane, but this time with the dual source heat exchanger. I do believe my colleagues explained the concept for the dual source heat exchanger. However, the system actually is able to work under the cooling mode and heating mode. Here we have the schematic for the heating mode, as you can see here. Again, the high temperature, high pressure actually refrigerants getting out of the compressor passes through the desuperheater, which we can use it actually for production of hot water, goes through the four-way valve, and from here, the system operates depending on the demand. So, for example, under the heating mode, the dual source heat exchanger working as the evaporator, as you can see here, and our actually the space conditioner heat exchanger working as the condenser. So the refrigerant actually after the four-way valve is sent to the space conditioner heat exchanger, passes through the evaporator, which is the dual source heat exchanger, and then going to be the suction for the compressor, and then we have the cycle. In this slide, we have actually the system, the propane dual source, but this time working on the cooling mode. So for this time, actually, after the four-way valve, the refrigerant is sent actually to the dual source heat exchanger, which works as a condenser this time, and our space conditioner heat exchanger working as the evaporator. So in this way, actually, the system is able to work both on the heating and cooling. So we tested all of the units except actually the CO2 ice. We tested under the first prototype. We developed two prototypes for each system. We designed, we built it up, tested. We found actually the problem, and then we went actually for the second prototype to see how we can improve and optimize the performance of the unit at the end. All right, thank you very much for your attention. That was the main concept for the heat pump.